everybody. My name is Samy Fodil. So today I'm going to talk about IoT and cloud economics. Cloud is like something that is used everywhere, not just IoT. And I'll talk a little bit about like where IoT fits there, but mainly about cloud because the cloud ecosystem is changing. Going a little bit to what you said about Gen AI, like all of these tools are running somewhere, right? And they're running in a cloud. And there is a race by like the hyperscalers, which are the big companies, the big five, AWS, Azure, Google, IBM, Oracle, like the big clouds, to be like, that's Azure, right? Microsoft Azure, to kind of like get like and secure part of the like or most of the market for them in the AI space. So and here I'm gonna talk about like the market, why some people are leaving what people call the cloud, but it's not actually the cloud. People are leaving like the hyperscalers, and then how you can build your own cloud, whether to reduce costs or to monetize on your own hardware. So that's kind of like what I'm gonna like go through, and then we can debate anything you see through the slides, and you can ask questions at any time. Okay, let's start with the market. So the cloud computing market today is roughly about $500 million, right? So that $500 million, most of it goes to a few companies, right?
$500 million?
$500 million. Half a trillion. I'm sorry, $500 billion. Yeah, you're right. Like 500 billion.
No,
Yeah, $500 billion. Yeah. You're right. Yeah, my bad. Yeah, it's actually here in the slide. So yeah, 615, which is roughly what the estimate is, and then by 2030, like this estimate says that it's gonna be like 1.6 trillion, but it's I've read some like predictions that says like it's gonna, especially with AI, gonna be like 13 trillion, stuff like that. It's gonna grow fast with AI. Everybody is gearing up, everybody is buying like the GPUs, everybody's trying to be the platform for AI. So when you look at that market, which is, thank you for correcting me, $500 billion, and you look at this little graph here, like most of it is the hyperscalers. Like this is the big three. Like you don't see Oracle or IBM there, but you can see AWS, Microsoft Azure, GCP, and Google is small because they jumped in late, right? And Oracle, you don't even see them because Oracle CEO thought that cloud was just a joke.
Although if you look at Oracle in the federal space, they're enormous.
Yeah, well, I mean, still, like they don't compete with, AWS. They were, the first in the market. They don't compete with Azure. They were the next ones, and then GCP, trying to catch up behind.
They had higher profits.
So again,
They had higher profits.
Oracle?
well, I mean, all of them have very high profits. Like cloud is a convenience business.
AWS is expensive.
Yeah, they're all expensive. They're very comparable. Like GCP is probably the cheapest of all three, but they're very comparable from a price perspective.
Depends on why.
Huh?
Depends on what you're doing.
Yeah, exactly. I think the main difference is like if you go on AWS, they have so many services and features compared to whatever other cloud you go and try. Like they built so many little things that you can use.
AWS price calculator, brand and your
Yeah.
And the problem is with all the tool sets that they give you is that, is that they're hooks, right? You get their free or low cost tools, right, that suck you in.
And not just that. I mean, they give you free credits to start with, especially if you're a startup. Like it give you thousands of dollars in credits, and then they give you free tier. But when if you don't like the moment you start having the real usage, you go beyond that, and then you see like $1,000, and then $10,000, and then $50,000 a month. They're very expensive. And then like from a corporate level and from if you're not a startup and if you don't get the free things, like they have a secret weapon that actually there is a book called Play Big or Play Bigger, I don't remember. And in that book, the author talks about VMware. And you guys know VMware, right? It's almost the first virtualization
Yeah,
software.
they're laying off like crazy this week.
Yeah, but when they started,
Well, because Broadcom bought them, they fired all the partners.
yeah, so when they started, people were like, why should I use a virtual machine? Right? I can just have like a big beefy server. People were just used to have like these big servers and they just, use like 0.1% of capacity, right? And then the banks will buy like racks of servers and rack every month, and everybody was doing that. That was how you do things. And VMware came up with this new idea, and the way they made it, made the market accept it, is they created features. So they trained people as certified people, and the certified people would preach VMware. The same thing, like this is why you have all this AWS partners and AWS certified people, and that goes for Azure and GCP, because these people actually pay AWS to give them a certification so they can go and make AWS money.
It's a requirement for their discount program to pay for the certification.
Yeah, there you go. Yeah, you still pay them and then make money
You
from
have
it.
to pay
Yeah.
for your discount.
Yeah,
Right?
exactly. Yeah, so
If I can just throw a comment in here, sorry. So data and cloud is the second highest expense for my company right now. It's just killing me.
yeah,
And it's an IoT networking platform for smart buildings.
yeah,
Where the rubber hits the road is I've got to have serious conversations with every client. So what data do you really want? Because I can collect everything, but I can't pay for it. You can't
Yeah.
pay for it.
yeah,
So step one in this whole conversation is figure out, what IoT data is important,
yeah,
because otherwise you're going to be paying
Right.
out the end.
And for your analytics, you have to figure out how much historical data you're gonna archive. Right,
Yep.
because the problem is if you have an IoT environment, if you have steady state data, you can actually make an assumption to replicate the data and reduce your storage costs, and then you can actually store all the anomalies. And then come into the percentage and recalculate your analytics that way, but it's strategic.
yeah. I mean, they like even like I think if I'm not wrong, like storing data on S3, like the ingress is free, but when you retrieve the data, you pay for it. Right. So they want you to store data. Like they have every means to trap you to storing the data there. So you pay for retrieving it.
But then from a requirements perspective, sometimes you have to have a certain percentage of the archival data stored in order to certify
You need to store
the
data
historical relevance, yes.
and you need it for compliance.
Yeah, that's right.
Yeah.
All the ED, right,
You see?
the government,
ESG.
ESG thing.
Oh, yeah.
All right.
Yeah, good. Okay, so this is a screenshot from a study I found about like how much money companies are spending on cloud, right? So small businesses, like most of them are spending up to $600K, right, a year on cloud. And for enterprise, they're spending between 2.4 and 6 million a year, right? And like this is not like running something large like a Google search or anything like that. This is very small, like maybe like tens of thousands of users, right? And you end up with expenditures that run around the millions. And I think if I remember well, Lyft spends I think 9 million a month on AWS. Right, just to kind of give you
I wonder how much Netflix spends.
They went to their own eventually.
They still have AWS.
and yeah, and talking about the big guys,
And Amazon ripped them off too, by the way. Prime,
but look at LinkedIn. So Microsoft bought LinkedIn, and one part of the deal was like, hey, you have to move to Azure. And recently they announced that they can't do it.
Cannot do it?
They cannot do it and won't do it. So no, they're staying on. They have on-prem. So LinkedIn have their own servers.
Yeah, but that's not, see, but they could actually go and decide it Azure. They could actually put Azure hooks into cited prep. You could do cited Azure.
Yeah, but you have to port the technology. So if
Yeah.
your software is not using like
You don't have to put all the technology, but parts of the technology.
yes, yeah, but even though and they're a Microsoft company, they said no. So
Right, they do that one.
yeah, so going to IoT. So IoT generates a lot of data, and then you need to access that data a lot from dashboards. You need to access it to process that data, and so on. Especially with AI now, like just imagine like having all that data, and then you need to crunch it and process all that data from IoT devices. Just the amount of data that's flowing to the cloud and from the cloud, and the amount of data that's processed. There is no real study for like, oh, how much IoT is spending on cloud. Like you just gave an answer, right? Like it's pretty big, right? Like IoT is a big consumer of cloud, and
But you could actually make,
expensive.
sorry,
yeah, you can go.
well, thanks. So, everything's IoT. Your computer's IoT. I mean,
If you wanna
you can make
see
the
it that
argument,
way.
you can make the argument that IoT is 100% cloud, right?
Well, I mean, I
Because
would
every
think
endpoint-
like
every
IoT is an embedded system, but
VMs IoT?
Yes.
I don't know, it's a virtual machine. It's already
It
a
doesn't
machine.
matter. Your machine's virtual. Yes.
Are a lot of the companies stuck with provider they might not? I mean, is it just really hard to move? So
it depends. It depends. If you build around, like if you're using services that are highly generic, like EC2s, just virtual machines, it's easy to move out. But if you're using more specific product, let's say you're using serverless Lambda,
I guess I'm just wondering how much downward price pressure is the for because if everybody could move easily.
It's expensive.
no, they can. You cannot move out easily. It's
The bigger
Like-
you get, the harder it is.
You're locked in.
it's you're locked in from a technology perspective, and then you have all these AWS certified people in your organization that are going to resist. Well, what I'm saying, AWS, I think Azure and GCP
Yeah.
certified people are gonna say like, oh no, like we have to stay on AWS.
Yeah, strategically, if you're gonna do a major upgrade to the platform, then slowly migrate the old legacy stuff. But it's pain in the ass.
My experience, and I've done a few, it's at least 6 months to go from platform to platform. Just to put that in perspective.
So
And that's probably for just a couple services. Like just imagine like
No,
they
cloud to
can,
cloud.
they can keep it.
no, like a whole solution with like hundreds and thousands of
At
services.
least
Oh, yeah.
6
Yeah.
months. At
I
least.
would think more, but
Depends, well, it depends how much you throw down for the migration.
millions of
And
dollars.
that's using like a professional migration company.
Yeah.
And that's assuming your customers even will let you.
That was actually the biggest challenge.
Right, because they
Was
will.
the customer
They're bought
acceptance.
into the security.
Exactly.
With whatever it was, AWS.
It's because your goal post move in terms of metrics and things as you move from platform to platform. And that is, 100% was the challenge, was the customer acceptance. Even though it's
And then-
millions of dollars, it was that. Was the whole
And the security, the security like issue is more like a myth than anything else, because like what is AWS? It's just infrastructure as a service. Like having a VM on AWS or having a bare metal server, it's basically the same security. It's what you built on top of it. How secure is your software? More like how secure is AWS compared to a server on Equinix? Like I would think that probably Equinix is more secure, right? I mean, a server in my garage is probably more secure than a VM on AWS.
I don't disagree.
Yeah,
Well,
The problem is the customer knows AWS, they don't know.
Yeah.
yeah. They don't know my garage either.
Well, it also depends on how you architect it, right? Like,
Yeah.
There actually could be one central station where you have lots of edge. Right?
Yeah.
That's also very impactful.
Yeah, for sure.
It's not.
But it's-
secure, It's more really compliance.
Yeah. Yeah, it's compliance, like people know the brand and stuff.
And
And-
instructions when the legal team gives you a subpoena for Azure and Microsoft services and how to do the security. There's not for all the other cloud solutions.
Yeah, for sure. Yeah. It's like convenience, like, why would you own a car use, Unix instead of Linux
Why would
and
you
pay
use-
for Unix licenses? I remember, Ed, like the Unix guys at the IEEE. So their answer was like, yeah, it's like people like to feel secure. Like, okay, I'm paying license for Unix. It's their problem. They're ensuring that it's secure. I'm not using
Yeah, but
it.
QNX also has telephony services.
They have what?
Telephony services built into QNX.
Well, I mean, so I think Tesla for sure are using Linux. I'm pretty sure that the new GM lineup of EVs are using Linux too.
Yeah, but 60% of all car companies.
Yeah, I know. And then the main reason when I asked the question was like they just feel more comfortable, like security and compliance and stuff like that.
Why people buy Red Hat, right?
Yeah, that's true. Yeah. Okay,
By the
so
way, I'm like this all the time.
yeah, so so if all these, so we know that the clouds are expensive, we know they lock you in, it's expensive to get out. They trick you with all like kind of things, like from certified people to free credits to free tier and so on. Like, how about running your own cloud infrastructure? So how hard can it be and how expensive, right?
It's pretty hard, and pretty expensive.
Yeah, that's what I'm gonna dive into. So, okay, so this is like this is the story that the cloud tells you, and it's been going around for some time. And they have the iceberg thing. I thought it was lame to get the iceberg picture here, but you can find it online. So they'll sell you this story. They'll sell you this story, and the story says like, okay, if you build your own infrastructure, it's gonna cost you here like $500,000. If you go for AWS, you're gonna save $160,000, right? Because you don't have all these IT people, and you don't have to pay for servers and maintain them, and so on, right? That's the story. That's the story being going on. And like when I say cloud, I mean the hyperscalers, right? Like not talking about cloud as like a way of running software, right? I'm talking the hyperscalers, and the hyperscalers have been increasing their costs, and that's called cloudflation. Right? They've been increasing the cost. There is no competition. Like when you're locked in, you're locked in. Like if AWS tomorrow says like, oh, we're doubling the price, are you going to say no? Like you can't, right? You can't just move your stuff. Yeah, you don't have a choice. You're locked in.
Choice. But you have decisions.
A lot of decisions, and all of them cost money.
Yep.
And they cost a lot of money.
And a lot of time.
Yeah, and a lot of time. So, but there is a company. Well, I mean, there are a lot of companies doing it. This company is doing it in a like public way. They're bragging about it, right? So, 37 Signals moved away from whatever cloud they were using, and what they did, they built their own cloud, and they claim in they saved like $7 million running their own cloud,
Right.
instead of using a hyperscaler.
And the bigger you are, the more that is true.
Say it again.
The bigger you are, the more that is true.
Yeah, the more you save, but they're not that big, so they were able to migrate, right? But if you're big, you'll have like issues migrating too.
So you said they rented servers from them.
Oh yeah, so yeah, a lot of people were like, oh, like now you have to manage servers and stuff like that. And the reality is, you can just rent servers, and they're using Deft, so they just like rent servers, and if a server goes wrong, Deft will fix it. Like all they cared about is having servers, IP addresses show up on their side, they add them to whatever they build.
So Dell has no software like
Yeah, it's bare metal, right? So Equinix Metal does the same thing. There are a lot of other companies like that. LeaseWeb, Rackspace used to do it. They don't do it anymore.
Away from it.
Yeah.
They're still making money.
Yeah, OVH, online.net, like there are a lot of companies you can just go and
Those companies been around for a long time, or
yeah, they've been around for a long time.
Good funding companies.
Yeah, yeah,
Hundreds.
yeah, if not thousands, like
so
there-
this
there's
all
so many
been
companies.
out there.
Yes,
This
yes.
is
The
the
problem
whole
is, and I'm gonna kind of go through it. The problem is developer adoption, right? So as a software developer, if you give me a server and say like, "Hey, go build your software on top of it," no, I'm not doing that, right? Like what software developers like to do, they like to like write software, push their code, and it magically deploys and scales. Right? That's what I want. This is why you have like the DevOps people, basically Flintstone people making all of these servers work, right? And then you have the developers. Developers don't care about like how my software gets from my computer to the internet, right? So we used to have sysadmins, like, and then like the stack changed. So we have like DevOps people that would make everything work.
Some heroes, all of them.
Yeah, and then now we have like a new term called like platform engineering, but it's basically just the same job evolved a little bit.
So under that model, where's security? How does that work? Only the sysadmin is responsible.
It's at every layer.
Yeah.
Well, I mean, so sysadmin is really manual work, right? Like it's like you're making the same thing again and again, running commands and stuff. When we're talking DevOps, is automation, so you're writing scripts and stuff. Like it's still very manual, like the little person inside the TV in Flintstone, right? It's still doing like manual things, but you're not doing repetitive things each time. So you have scripts and some code that takes care of the repetitive things. Yeah. So it's there is DevSecOps. You script that too.
It's
So
not
you have
DevOps
tools.
anymore. It's exactly what he said. It's called DevSecOps now.
Yeah. So instead of having somebody like trying to do all the like stuff manually, like, oh, let me scan and then let me do this and that. Like when you push your code, when the developer pushes the code, there are routines and like scripts that will run the code through some tests. They're like, oh yeah, it seems like you're opening a new port. Hold on, let's talk about it. Or it seems like your code has potential for a SQL injection, something like that. And then it will, it's called like the CI/CD pipeline. So in the CI/CD pipeline, something will happen like this. So you're like, okay, I'm not deploying that.
What about a DNS attack?
A
Who's
what?
responsible for that?
A what?
DNS.
DNS attack.
Yeah, I mean, DOS attack.
DDN.
Yeah, or DDoS, right? Yeah. I mean, that's kind of like you should have like a team of people that make sure the infrastructure is working. So that's the DevOps team or site reliability
That was
team.
the question I was asking. Between
Yeah.
DevOps and bare metal. Getting higher.
Yeah.
Right? Gotta have that security. level.
Well, if you run on environmental, you still need to have like your DevOps team doing the whole thing. Like you always will have like.
Even if you don't
Yeah.
AWS.
You're gonna think I'm still at school the way I raised my hand.
No, you go. I'm sorry. Yeah, I wanted
You're
to
being
jump in.
fine. The whole security model, back to your question about security. Edge security will continue to be important, right? The reason that a lot of these cloud vendors are growing the way they are is because they don't just have peripheral security, that they have what's called or they offer what's called a zero trust environment for every interaction between every principal. It doesn't matter whether it's an application or a user, that there's this level of indirection that every time they make a request, that there's a party in between that says, does this person have the authority to access this resource? Or does this resource allow somebody who is not in this select group of people? So the whole security model, I mean, it's already available in the big cloud vendors. I think that's one of the reasons that they keep growing is because they actually do offer a zero trust environment. They don't rely on the edge security anymore because edge security no longer works.
Well, I mean,
Yeah.
okay, so what you're talking about is basically in the application layer, right? Like these are services they offer and you need to implement them, right? Like if you don't implement them, it's not gonna work.
But it depends on the cloud vendor. I'm familiar with AWS, so they offer these as services.
Yeah.
They assign a role, principles, and so they have a complete attribute-based security model
Mhm.
that you leverage as a service. You write the application, but then, two applications talk to each other. They need to kind of register with this IAM system so that they can consume a certain roles, certain privileges.
IAM is fun on AWS, super fun.
Well, it is. It's a good system, but it has scalability challenges. You think, and so, yeah, there's issues with that, but it's not entirely true. If you're using infrastructure as a service, a lot of times you still have to build your own, but if you're using their services, and this goes back to the lock-in, it's not just the richness of the services, it's that they offer this very locked down security environment. And AWS has such a big head start over everyone else.
Yeah, no, I get it. Like and that's kind of part of the logic here. Like they have all these services that build them. Like it's so easy to use them. They lock you in, obviously, but it's like, it's so convenient. Just use them, but you're locked in, right? Like that, and more services use will lock in you. Now, it's not impossible to build your own like zero trust services with open source. There are solutions to do that, right? On bare metal. It's just, do you have the know-how, right? And that's what I'm kind of like trying to get to, like in here. But you're right, yeah.
Sorry.
No, you're good. You're good. Okay, so if we want to build our own cloud, we need two things, right? We need servers. We already talked about our virtual machines. Already talked about that. That's easy, right? You can grab it from the company that's renting them. You can use your own servers if you already have that. Maybe you have some servers in your garage like me, and you can use that. It really, yeah, there you go. Yeah, use Chris servers too. Okay, so yeah, I mean, there are a lot of options there. It's not the hardest thing to do. The real hard thing to do is the second one, building a platform, building what the developer is going to expect, right? So servers, no problem. Already talked about that, but building a developer-friendly platform. So that would do the CI/CD. That would eventually give you features to integrate security, zero trust, and that will scale your software, orchestrate, like let's say a container or a VM goes down and needs to orchestrate that. You need load balancers to distribute the request. You need a lot of little services here and there to put your software together without, building a complex piece of software that will take forever to build and it's not maintainable. So generally speaking, and I like it started like with sysadmins and then became like DevOps, and then now we're talking about platform engineering. But at the end of the day, if you want to build something like a platform that's internal, like it generally takes like roughly like 6 months, $250K. That's a basic, like internal platform that has a CI/CD. Developers have a platform to interact with and so on.
How many VMs?
Well, this is not about VM. So you get your servers, and then you have a platform. So as a developer, I don't have to talk to a DevOps person and say like, hey, can you provision that for me? So I have a little platform. I can select it from a catalog.
Onto the physical servers.
I don't have to deal with physical servers. That's the thing. Like the platform is it's a layer between the developer, or a bridge between the developer and the servers, right? So I just go there and say like, okay, I just want like select the registry. So like, okay, it's a MySQL server and it's a container that runs Node.js or something like that, and that's all I need, right? And I do some config or whatnot, push my code, it's built, and it runs on that platform, right? Okay, so and that thing is complex and expensive, right? So that's the most complex thing. So it's not It's not like managing servers. Managing servers or the IT of the service is easy, right? Like you can, if you rent bare metal, they're doing it for you. What's hard is making the servers usable for the developers, right? And that's hard, that's expensive, that takes time to build. Now, what's the return of investment, right? Like we've seen that 37 signals saved like $7 million, right? I did some math here and kind of like came up with this number per server. So if you go for a entry class server, like 128 gigabytes of RAM and like one good, CPU, you're roughly going to generate $2,000 to $5,000 if you're trying to monetize the server, right? And if you're trying to just cloud exit, that's 90% saving costs over a cloud provider. You're going to save about 90% of the costs.
So you're seeing savings.
Yeah, saving around 90%. So if you're like you were spending like $1 million in AWS, now it's only 100K a year. It doesn't matter. If we say $1 million, a year, you're gonna divide that by 10.
90% savings.
Yeah, you're saving 90%, like moving out of the cloud. That doesn't account for like the migration and stuff like that. Right? Like depending on how much locked in you are.
You need to go and run all the auxiliary services that are automated.
Say it again.
You have to have other FTEs to run the auxiliary services.
What do you mean by FTEs?
Full-time equivalent.
Oh yeah, for sure. You need people, and we're gonna talk about you need people, and these people are going to, let's say, build the platform and then maintain it. Right.
They trade on your TCO.
Yeah. So then, I mean, like this cost is like this saving is gonna be like plus minus, but it's gonna be close, right? 70%, 90%. You're still gonna save money, moving your and depending on how much vendor locked in you are.
Let's clarify this though. So as an example, I had about a 50K a month rack space bill.
Okay.
Moving to Azure got me under 20K
Okay.
a month.
Well, Rackspace servers are expensive.
So I just want to point out,
Yeah.
depends if you're looking at a managed hardware service versus you managing service. So that number is true when you're managing.
Well, I mean, okay, so I used Rackspace before too,
Yeah.
and they're
very
expensive. Like a 32 or 64, I don't remember, gigabyte server was like $4,000.
Yeah.
And I ended up using like servers somewhere else that were costing me like $300-400. Right? Like Rackspace is expensive for no specific reason. I mean, the proof. I mean, they just pivoted from that. Like they're not the best
To
there.
clarify, when you're looking at managed hardware portfolio versus.
Well, I mean, even if you do Equinix Mel, right? Let's say, and I use Equinix Mel. Like you can get a server here in Dallas for around $300.
Exactly.
And it's managed for you. Like if the server goes down, they'll reboot it, they'll replace
You
it.
get away from the Rackspace.
As long as you don't
That's
use
what I was
Rackspace.
pointing
Yeah.
out.
Rackspace
That number
is.
is true there.
Chris, we used to do that. I used to be on the board at August Creek.
Yeah.
The data center down at T-Bell. And we used to have that server, and we used to have the pure colo. I used to be on the board of data center. We used to have the pure colo. We used to have the managed server. You could do all that niche stuff, and a lot of people did. But you do need a lot of expertise to do that.
Yeah, but I'm just saying the cost can.
Yeah, expanding.
Way.
Yeah.
Rack space on the top end and one of the local colos being very cheap.
Yeah.
NTT would be in the middle. Right?
Yeah. And then it also depends. Like you can get bare metal from AWS. They're like 10K plus.
Yeah.
Right. And then you can get a beefy VM, and they're also like $5,000 a month. Right. Like it really depends on what you.
That's the thing I found when I'm pricing all over the map.
Yeah.
It's like super crazy.
Exactly. Yeah. Okay. So we all agree that servers are easy to get. That people that get these servers and they manage them. If they go down, they fix them, they write new servers for you. All of that is pretty much figured out. The question is around like, how do we don't spend 6 months plus and $250K building a basic platform? Basic developer platform. And this brings us to what we've built at my company. So we built a cloud built-in solution. It's open source, so you can go to github.com/Taubyte and you can see the repos there and some guides on how to deploy your own cloud. It's very easy to deploy. I'll guide you through some screenshots here, and it's autonomous. And that's one important point. So autonomous, like we have self-driving cars, right? Why do we have to have Fred Flintstone running servers and doing DevOps things or building platforms again and again, right? Like we should have. No, we need self-driving cars. We need servers that can discover each other, talk to each other, like heal by themselves, be autonomous, right? We shouldn't have to configure IP addresses manually and configure like host names manually. And yeah, there you go. Or deal with Route 53 and stuff like that. So most of these things should be done automatically. What we need to offer is an interface to the software developer saying like, hey, what domain do you need to use? And the developer say, like, oh yeah, I want to use like somedomain.com, and the platform does everything else for the developer. They don't have to go to Route 53 and try to configure load balancing and stuff like that. Or
2 days later, I got it.
Yeah, there you go. Right. And then if I change something, I need to go back and then try to update it, stuff like that. Okay, so this is a screenshot of a tool called Sport Drive that we created. And you basically define all your servers. You define keys. So every server, it's a peer-to-peer network. Every server has an identity. I think I should have had like a diagram or something. I'm gonna explain it. So every server has an identity, right? Every message is signed and encrypted. Like one server cannot send a message to another server claiming that it's another server, right? Everything is verified. Every message is signed. Every message is verified. And every server has a private and public key. So you deploy it in one step. Servers, they discover each other. And then they're like, hey, what do you have? You can say, oh, I'm doing DNS and DNS load balancing. The other one's like, oh yeah, I'm running like gateway and I'm doing like layer 7 load balancing. And another one will say like, yeah, like I'm doing compute, can do compute, storage, so on. And we call them protocols because they're not like, there is no central entity providing a service. These are protocols where nodes communicate between each other to implement a feature, which is, like load balancing or storage or stuff like that. And then in a few minutes later, you have like something that looks like this where developers can log in and build their software. So this is like right now it gets you to create a serverless platform that has like compute, storage, database, front-end hosting, DNS, and PubSub or messaging. Yes.
Can this work across regions?
Yes.
If I have a set of servers.
Yes, you can have a server here, a server there.
How do they discover?
So it's edge. So the whole platform is edge native. And then when you create your network, you need to have nodes acting as what we call elders, right? And they're used for a process called bootstrapping. So the elders are there. Every node knows the elders. You can have like as many as you want. And when a node starts, if it's new, it doesn't know anybody, it goes to the elder and say like, hey, tell me about the network, right? And it will tell it about the network and will connect. And then they exchange data between themselves. Say like, hey, I'm here, I'm running this service and stuff like that.
It's hub and spoke sort of kind of.
No, it's really a mesh network.
Okay, but
So
you
it's-
still have the elder, which is kind of
No, the elder is just used to bootstrap.
okay.
And then you don't need it after that. It's like let's say, and any node can act as elder at the same time. So you can have like a DNS server and being an elder at the same time. right? So you just need like a node that you can connect. Say it again?
It's kind of a dynamic, because anything could act as a hub.
Yeah, it's dynamic. So every node maintains something called a DHT, or distributed hash table, and the DHT has info about itself, but also other nodes that are nearby.
The initial discovery is by the public.
The initial discovery is through like a bootstrap node. Yeah, when the node is new, when the node is like already bootstrapped, they have a local database that they keep like nearby nodes, and they don't have to reach out to the bootstrap again.
One question is, let's say we install in Dallas.
Yeah.
The infrastructure, whatever.
Yeah.
And then so these servers are already identified.
Yeah.
Discovered each other. Now we're trying to configure something in CAD.
Yeah.
And we want, I think you're saying during the bootstrap process.
Yeah, you give it the IP of the other one.
So you have to at least define.
So there is the public IP relation.
Well, once it discovers it, that's it. Like it's like, what's your name? Sri, right? Let's say I'm new to Dallas and don't know anybody, and somebody told me like, hey, go talk to Sri. And he said like, hey, you know, like I can help you with this and that, but if you need that other thing, go talk to these other people that I know too, right?
I still need to continue my public IP address so that you can communicate.
Well, if you're not providing any service, you can not be there anymore.
But how do you discover if I?
So you provision.
Well, I discover, okay, so I reach out first, say like, give me a list of nodes, and I get that, and then these nodes now are in my local database. So next time I restart, I just reach out to them.
How are they identified? Because it's global information.
So you're.
Yeah, it's all, yeah. So when you start one node, it's only itself, right? Then another node comes up, it connect with Dallas, say like, hey, Dallas, I'm California, know that I'm here. And another node, a new node that let's say it's in Montreal, can connect to California, not to Dallas, and say like, hey, California, who do you know? I'll say, well, you already know me, but no, there is a server in Dallas, right? And then they communicate between themselves. So Dallas will also discover Montreal as well. Right? So there is a process of discovery going on under the hood.
You have to define at least one node in front on it.
Yeah,
So first time run.
you should have a bootstrap, preferably have at least 2 or 3, because if one of them goes down, you have the other.
I didn't know if you were doing first time run one and then letting it populate.
No, well, the first time when the node starts, it needs to know where to start, like who I am, like who should I know. So it goes to, you can connect to 3 bootstrappers and try to get as many info as
Just trying to
possible.
figure out first time run.
Yeah,
That's where you were kind
We're
of
kind
going.
of confusing.
One first time run, what do you do to set that?
A public IP typically needs something that somebody outside on, right? I think
a public IP is an IP that's routable on the internet.
But I think we're confusing that with, if you come up and you want to find some kind of a service.
Yeah.
You don't know where the service is, and so you have to talk to a party that knows where that service is located. That party that knows where the service is located doesn't have to be public. I mean, it just needs to be visible to them.
Yeah, it could be a local,
So
yeah.
It's a little different than anyway.
Yeah, it could be a local network. I mean, let me give you another example. Let's say I rack another server in California, and instead of giving it like the public IP of California, I give it the private IP of the other server. That's enough. You just need to know one node and communicate with that node to discover the rest of the network.
Right, so follow-up question. So are you trying to store or register all these servers in your database? So that you can.
Well, there is no one database. It's called a DHT. It's a distributed hash table. So every node has a distributed hash table, which has a partial view of the network. It's not like the same. It's like a partial view. And it's like every node will try to know as many nodes as it needs at a specific amount of time.
So it has a copy like cryptography.
Yeah, it has a copy like, okay, I know these nodes. I know the public key for them. So when they send me messages, I can verify and stuff like that. Yeah.
Are you doing anything with a blockchain? I figured out that.
I mean, there is no blockchain in here, but it is a distributed network. It's a peer-to-peer network.
Hashtable is following the same pattern as blockchain.
Yeah. I had the question.
Similar, but not the same.
Yeah.
Oh yeah, so
Similar but different.
Yeah. I mean, well, peer-to-peer network has been around for a long time, but I worked at Facebook and we use private BitTorrent to provision software. It's faster, and there is no real point of failure. Like it's not, oh, the server went down and we cannot deploy anymore, right? So it's pretty powerful as a technology or a technique to build reliable networks or solutions. So this is some stuff you can do. Like once you deploy it. So this is a network that I built over screenshots from a network I've built over a weekend, which is open source too. It's called 8bit.ws. And it has a plugin, which we call Satellite, that can do LLMs or large language models and exports that to serverless functions. So you do something very simple. So SDK.predict, I give it the prompt and then some parameters. If any of you guys is familiar with that, like top K, top P, the patch and stuff like that, you can tune all of that if you ever use OpenAI API or something like that, you'll know. And then you can also host the front end there and have something that looks like ChatGPT, and you can talk to it and gives you answers. So in this case, it was running Llama V2, the model that was published by Facebook. That's it, and then you can do way more. Not just that. Like you can add any kind of extensions you want, and it comes with a lot of stuff. Like you can do HTTP, you can do DNS, you can do storage, database, and a lot of other things. That's it.
License, Vincent, and Julie
Yep.
Enterprise.
So question, so you have these AI interfaces like
Yeah.
GPT. Aren't you basically going into a neural network?
Yeah, so this is what happens, right? So when you do an HTTP request, right, it goes to first it does DNS resolution, right? So that goes to a protocol we call SEER, right? So number of nodes in the network could be running that. SEER it's intelligent. It knows who can do gateway. So it will send you to a gateway. So you don't have to configure all of that, the Flintstone way, right? It just happened by itself. And then you go to the gateway, and gateways know what the compute nodes. So gateway will redirect you to a compute node that can run the function. And inside the code of the function, if I go back here, instead of the code of the function, you have something that's communicating with the satellite, which is a site process that is running a large language model, right? In this case, it's running Llama V2 on the same host, and it has a GPU. It's running Llama V2. So the platform, in addition to compiling the developer code and pushing it to production and distributing over the network, also handle the request and will distribute the request over all your GPU nodes. Actually, I have a company that's using Taubyte to run their own LLM on, weirdly enough, Mac hardware, because they discovered it's more efficient.
Are different than neural networks. So the LLM is like a big matrix.
Yeah, instead of saying ChatGPT, LLM is a GPT. It's a recurrent neural network. It's bigger, but yeah.
So an LLM is the way it
It's a neural
processes-
network. Yeah.
the way it processes information is much like we do with normal processing today.
No, it's really it's a neural network. It's a format of neural networks. So when you think about neural networks, there are neural networks that are used for vision. For example, YOLO, right? YOLO is a neural network architecture that is used for vision, like to detect objects and stuff like that, right? LLMs are like neural networks, but they have a different architectures. Yeah.
So I got the important question. How do you make money doing
Oh,
this? I mean, that's the important question. right?
yeah.
How much
And-
is it and how do you make
And
money?
okay, so we're actually going to push a little calculator, and you like that. You can play with it once we do probably early next week.
You know, like an analytical calculator?
No, just
Like
to calculate the cost if you, so you can deploy your own network using all the open source tools. And you don't have to pay anybody anything.
But I have
But
to build two really large networks.
yeah, so it doesn't matter. They can be as large as you want. If you only use the open source, it's like only your efforts or elbow oil or whatever they call it, right? You don't have to pay.
Elbow grease.
Elbow grease, right? There you go. Right?
By the way,
Yeah.
just for your edification,
Yeah.
red was a Luddite, but orange was actually.
Okay. So yeah, if you use like the open source, what's open source out there, you can deploy it on millions of nodes. You don't owe us a dime. Right now, we have tools or stuff that makes it way better. So this graphical interface, that's a SaaS. So you'll have
SaaS solution.
So that's a SaaS. So you have like concurrent. So if you don't use this, you can use the CLI or command line. That's open source too, right? And developers will have to. But if you want like a nice user interface for the developers, that's a SaaS, and then it can be branded too. So instead of showing Taubyte on top,
And that's
it'll
how
show whatever.
you make money.
Part of it, yes.
Okay.
Yeah, you can also have support, just like a Red Hat support, and that gives you access to this guy, Sport Drive, and observability tools. So Sport Drive, like you deploy in one step, but if you do it yourself, right, you'll have to. It's a 3-step process per server, right? So you'll have, if you have 1,000 servers, it's like three steps times 1,000, right? Where like here, it's just running the command once. Given you have all your servers configured like in a YAML file. That's it. Yeah.
You didn't bring any screenshots of your GUI front end, which is actually kind of nice.
Yeah. And yeah, so I have, yeah, and actually you can play with it. So if you go to console.taubyte.com, I can say you use the open source version, you can still use this. It's not gonna be branded, and it's gonna be limited to 3 concurrent users. Yeah. So, but if you have a lot of developers working with this, like
Right.
you'll need to get like SaaS licenses.
I have to build something that's 26,000. Yeah.
Sure.
What? Yeah.
Yeah, I mean, you can do it.
I got 40 servers on Azure right now.
That's a lot on Azure.
This chassis for setup.
Yeah, I know. I'm spending a lot of money on it. Yes.
Yeah, I
thank you.
know.
Yeah, so
Sourced out big ones like that.
basically like we have companies running LLMs, so they're cheaper, and they don't have to spend, they don't have to have a DevOps team and spend money on a DevOps team and or a platform engineering team or anything like that. We have companies running like Edge AI on the platform too, and building dashboards and stuff. And then we have companies that are building their own clouds. So they're kind of like basically priming to compete with, a Cloudflare or a Fastly or a StackPath, stuff like that.
Yeah, I was supposed to say CDN caching could be really.
Yeah, it has CDN and caching built in. And that goes back to the DHT and how we address
No
files.
problem with video recording.
A streaming video?
Yeah.
We don't do streaming video yet. So you can do messaging, but not streaming videos.
That's a problem.
What kind of streaming you do from cameras? Yeah, if you're streaming, if you're streaming to a service that would work. What I'm saying we don't do is caching. Huh?
We built a new social media platform.
Yeah, I mean, streaming per se, like let's say streaming like a YouTube or something like that. It's something different. We don't have
Well, it's gonna be
all the features to do things like that.
Yeah, it's gonna be from, one account to thousands.
One to many.
From what?
From
From a camera or from what?
If you see a camera, phone.
I'll have to look at it.
So that's-
What's the frame rate?
Right now, we 30 frames a second.
Yeah, 30 frames a second. So like what,
30, yeah.
H265, 264, RTSP.
Right, it's, you know, right, choose.
Yeah.
64.
Yeah. I mean, generally when you yeah, I mean, I don't know. Like,
Not the engineer, I'm just.
yeah, I mean, I'm happy
This is
to,
like
I'm happy
little
to look at it
Videos
and then,
on TikTok or-
I'll show you later.
yeah, you can also build satellites or plugins that will do just RTSP. It's not like,
Yeah, that's super laggy. If you
what-
talk about RTSP, it's really
what-
laggy
what
to
do you
set
mean?
up. Because it takes a long time to spool up. Or if you're talking about RTSP versus say H.264.
well, I mean, RTSP is just a transport.
Yeah,
And H.264 goes inside
yeah,
the RTSP.
Yeah. You're doing camera RTSP, it's very slow.
My experience is pretty good, but
It's
Right.
depends if you're depends.
well, I mean, what I'm trying to say is if you are trying to do like streaming and cache streaming, that's something more complex. You probably need to build like a satellite.
Yeah,
or a
there's
plugin.
tricks you do on social media for preloading stuff before you see. Yeah, there's all kinds of
Yeah.
things.
Yeah. So yeah, caching video, especially live video, is a
That's-
complex problem.
What you don't realize is if you're scrolling, it's cached so much of that content.
Oh, no, I do realize that, yeah.
And that's, it fools you as a human because it's already grabbed so much of the video in advance. It anticipates what you're gonna watch.
Right, yeah, no, I get it, I get it.
Because otherwise it's, you know, super slow.
Yeah.
That's why, like, if you're doing camera feeds or live vid, like security feeds, there's always a log line. Because you can't cheat.
Yeah, on purpose.
Yeah, like camera, like one of the use cases is camera, and it's processing it with AI, right? And I think RTSP is used like at the edge from the camera, but it depends on the camera. Some cameras are not used good with RTSP.
How,
I agree.
how would you do like video collaboration? How does that work?
What do you mean by video? I mean, this is a developer platform. You need to build things on top of it.
All right.
I mean, it doesn't come out of the box. It's like, oh, there is a
He's
video.
building infrastructure. His platform does infrastructure. Well, that's,
Yeah, so it's,
Okay, I'm just-
yeah, I
I'm
think
just thinking all I see what the pitfalls are, that's all.
you would need to build you're talking a little application layer, so you'd have to build that on top.
Yeah.
yeah, you'll need to build new features there or port your existing features depending on how much vendor lock-in you have today. Right? Like, if you have like a lot of vendor lock-in, you know, that's gonna be harder.
Like if you were to do a lot of things that you do on AWS, you could do it fraction.
It's mostly open source. I was going at it.
But I mean, I can shoot you info and you can send that to your technical team and they can play with it, see if that's what they want. Yeah.
Two questions. So one, so whatever the infrastructure you're building is truly building a networking, like whatever the network is.
Yeah, so you have your servers or your VMs, and then you deploy the software on top of it, whatever way you do it, and then they discover each other, and then it provides you with a platform for developers. So the interface with the platform. So you have two ways to interface with it, right? So there is the user interfacing with it, like your end user, right? It hits it like whatever you build on top of it, and then it gives it like a website, and respond to an AI request, stores IoT data, whatever. From the developer perspective, the communication goes through Git. I don't know if you know what that is. So GitHub.
Yeah.
So we use a best practice called GitOps, or everything is Git operated. So you don't. The problem with DevOps and the whole infrastructure thingy is you think you're doing things well, but you know what? Like there is a guy named David that hit an API to do something, and then everything goes wrong, right? And we don't know that David did it. We don't know when he did it. But with GitOps, everything goes into like through Git, and you have a trace you can roll back and stuff like that. And this is why that's the way you communicate with it.
So if you compare this with AWS, right? So
Yeah.
probably you're doing VPCs or anything you could use it for security.
Yeah.
And I think I know you were talking a little bit when I came into IAM. So if I have to restrict, let's say if I want to create an app mesh with this service, I want to say that one server is going to have full access to another server. So that's also configurable via this access. Is that correct?
So it depends. It depends. So we have a concept called smart ops, and these are serverless functions that you can use to implement whatever logic you want. So you could say like, hey, this code can only run here on this server, or don't talk to that other server, or anything like that.
No, I'm not talking about code. I'm talking about network level saying that, hey, this server should only talk to the server.
Well, the only way, the only, like today, the only way to do that is really to like put some firewall rules or anything like that. So, but the idea is servers should be able to, like, it's like servers or nodes are communicating between each other and promoting what they can do, right? It's not like, hey, you cannot talk to me, huh?
It's all on one side.
No, they can be in different. It's a peer-to-peer network, so servers could be in different like subnets and networks, and you can even configure some nodes to act as tunnels. So nodes that are behind firewall can still contribute to the network. But there is no concept of, hey, this server cannot communicate there. It's not impossible to implement, but think about it for a second, right? Like if we implement something like that, we go back to Flintstone. That's the problem, right? If I say, oh, you cannot talk to that, like it would be better to maybe figure out something more high level that says like maybe like some kind of layers or something, like only servers in a specific layer can communicate between each other, and that would be like something that would be interesting to implement. But like implementing like low level, like hey, this server cannot communicate with that server, feels like going back to Flintstone.
But how does your access work? Right? Let's say if you want to allow access.
So the network has a key that's secure to the network, and every node has private and public key. So communication is secure, is verified. Like a node cannot forge a response of another node, and nodes only communicate with nodes that have the same key that themselves, right? Same like security key. But except that, like we don't have mechanisms that says like, oh, this node cannot talk to that other node. I personally never thought of it, like you're the first one bringing this up, but it also feels to me like we're going back to Flintstone, where like I'm trying to, like we need to, like the idea is to remove the human ops factor, not add more human ops factor, if it makes
I
sense.
think one of the challenges we had was if we wanted to wrap earlier, cloud providers used to support APIs. Now I think they're getting into APIs. They want to do at the network layer. So they want the security implemented at the network layer so that it's highly secure than APIs.
Well, I mean, like I said, like there is security on the network layer, but it's not a kind of like one-by-one rule layer. Like I said, like if you come to me and say like, hey, here's an elegant way that we can define a high-level mechanism that says this node, a specific node cannot talk to other nodes or have to segment the network, it would be cool. Like we could think about it and maybe implement it. But saying like this node cannot talk to this node, that's like too much granular and kind of brings back the whole experience to
You're in the policy.
Flintstone.
He's trying to do everything where it's autonomous.
Yeah, autonomous. Yeah, we want something that says like if you come up with an idea, so like a like yellow car and red car or something like that. That's the mechanism.
Because as soon as you add it in, it's trusted.
Yeah, like if there is a high level way to say like, okay, we put our nodes in like we give them like, let's say a tag or a color, and then you say like, oh, only these tags can talk to each other. It's high level rule. You define that, and you're not like going and say like, oh, you can talk to that. And even if you do tags, like I'm pretty sure like some people will go and create tags for each server because it's what people do, right? Then we'll go back to Flintstone.
did this idea come from Kubernetes by any chance? Because I think whatever you're saying is pretty much equivalent to Kubernetes on containers now. This is on partial install.
Yeah, so it's like it shares no code with Kubernetes, and we want everything but to be like Kubernetes, right? Like it's made for developers, not operators, and it's meant to be autonomous, not configure every aspect of everything. Yeah, and then it's meant to like scale horizontally, which is like something that doesn't happen with Kubernetes either.
And there's not gonna be any feet on the bottom of the autonomous car driving.
Sammy, can you stick around a little bit longer?
Say it again?
Can you stick around a little
Yeah,
longer?
sure,
Get
sure.
us more questions? Anybody have any burning questions that they think that would be beneficial? Thank you.
Okay.